Right now, everything you call the cloud is sitting in a building, a real building, in a real town that you could drive to. Your photos, your files, your messages, your backups, that video you watched last night. You think of them as up there somewhere, weightless, wireless, floating in a sky called the cloud. But nothing is floating anywhere. Every one of those files is a physical thing, written onto a real disk, inside a real machine, in an enormous building you have almost certainly never seen, that hums 24 hours a day and drinks as much electricity as a small city. So let's go find it. Let's follow one file off your screen, out of your home, all the way to the building it actually lives in, and walk inside. By the end, you will never say the cloud the same way again. Start with the moment you save something. You take a photo and a little icon spins, and a second later it says, backed up, safe, in the cloud. And it really does feel like it went up, into the air, into nothing. It didn't. When you save that photo, your device does the opposite of floating. It pushes that file down out of your phone onto the very same wire that carries everything else you do online. The file leaves your hand, leaves your home, and heads out into the world looking for one specific place to land. So forget the sky entirely. The cloud was never above you. It's out there, sideways, at the other end of a wire, in a building with an address. And that's the building we're going to. Now, where does it go? It goes out through your internet provider and off across the network. And we made a whole other video about that journey, about the cables under the ocean, and the way data travels the world. Today, we're not following the road. We're going to the destination because the road ends somewhere very specific, a data center. And here is the first thing that breaks the illusion. There isn't one cloud. There are thousands of these buildings scattered all over the planet. Watch the map. Every one of those dots is a data center. Some are the size of a room. The biggest are the size of dozens of football fields, sitting in fields and deserts and quiet industrial parks, most of them completely unmarked. You've probably driven past one without knowing, and your file is heading to one of them. The map zooms in, past the country, past the town, down to a single building. Long, low, windowless, a parking lot, a fence, a road you could turn onto right now. This plain, giant box is where your photo is going to live. So let's do the thing almost no one gets to do. Let's walk inside. And the moment the doors open, the whole idea of a magic cloud dies for good, because inside is not clever and it is not mysterious. Inside is a warehouse, full of computers, row after row after row of tall metal racks, stretching further than you can see, and every rack is packed with machines called servers, stacked one on top of another, dozens to a rack, thousands in the room, little lights blinking, fans roaring, a wall of sound and heat. And a server is nothing exotic. It's a computer. It has the same basic parts as the one you're watching this on. A processor, memory, drives, just built to run flat out, forever, and never be switched off. No screen, no keyboard. Just a flat box that does one job and does it without stopping. Somewhere in that ocean of blinking machines, on the drives inside one of those boxes, is your photo. Not in a sky, on a shelf, in a rack, in a row, in a building. That is the cloud. It's this room. But a room full of computers has two problems, and solving them is what a data center really is. The first problem is heat. Every single watt of electricity that goes into all those machines comes back out as heat, almost all of it. Thousands of computers running full tilt in one sealed room would cook themselves in minutes. So half of this building isn't computers at all. It's cooling. Giant air handlers, chilled water pipes, sometimes just enormous fans pulling in cool outside air, all working nonstop to carry the heat away. A data center is, honestly, as much a machine for moving heat as it is for storing files. The second problem is that it can never, ever stop. If your bank or your hospital or your photos went dark every time the local power flickered, the cloud would be useless. So these buildings are built to shrug off failure. Outside, rows of huge diesel generators wait, silent, for the instant the grid drops. And to cover the few seconds before those generators roar to life, whole rooms are filled with batteries, ready to take the entire load without a flicker. Add it all up, and the numbers get staggering. A single large data center can draw tens, even hundreds of megawatts, as much electricity as a small city, day and night, and there are thousands of them. By common industry estimates, all the world's data centers together already use somewhere on the order of a low single-digit percentage of all the electricity on Earth. And with the boom in artificial intelligence, that share is climbing fast. Now here's the part that should make you feel a little better about trusting all this. Your photo is not sitting on one drive in one machine, hoping nothing goes wrong. Drives fail all the time. In a building with hundreds of thousands of them, some are failing right now. If your only copy lived on one of them, you'd lose things constantly. So they don't do that. The moment your file arrives, it's copied. Not once, but several times, onto different machines. And usually it doesn't even stay in one building. A copy is quietly sent to another data center, in another region, sometimes on another side of the country or the world. So think about what that means. For a single photo to be truly lost, the same file would have to fail on several machines at once, and in more than one building, hundreds of miles apart at the same time. That's why the cloud feels so solid. Not because it's magic, because there are always more copies of your stuff than you think, sitting in more places than you'd ever guess. And that's the real shape of the cloud. Not one building, many, grouped into regions all over the world, each holding copies of each other's data so that any one of them can fail and you would never even notice. So now the payoff. You open the photo, you tap it on your phone, and instantly it's there. And you already know what really happens. Your request goes back out to the network, finds the nearest building holding a copy of your file, and that server, one flat box on one shelf in one enormous humming room, reads your photo off its drive and sends it back to your hand in a fraction of a second. That's the whole loop. It didn't come down from a sky. It came back from a building, a specific building with a parking lot and a fence and a power bill that you could, if you really wanted to, get in the car and drive to. So here's the whole thing, laid out. You saved a file and it didn't float up into anything. It left your device sideways, down a wire, out through your provider, and across the world to a data center, one of thousands of plain, giant buildings scattered across the planet. Inside, it landed on a drive, in a server, in a rack, in a warehouse full of humming computers, kept alive by as much cooling and backup power as a small city needs. And then it was quietly copied into other machines and other buildings, so it could never really be lost. When you asked for it back, the nearest copy answered in an instant. There is no cloud in the sky. There never was. The cloud is thousands of the most physical buildings on Earth, full of real machines, drinking real power, holding your entire digital life on actual shelves you could walk between. That's the pattern behind almost everything you touch. Your power, your water, your internet, your files. Each one is the quiet end of a system that is far bigger and far more physical than it looks. So the next time your phone says backed up to the cloud, picture it. Not a sky, a building in a field somewhere, with your photo on a shelf inside it. This is Veyor, where we trace how the modern world actually reaches you. Next time, we're leaving the internet behind and following something you light every day without a second thought. How natural gas travels from deep underground across a continent of pipes all the way to the burner on your stove. If you want to see that journey pulled apart on the map, subscribe, and I'll see you there.